Steve's Physics channel. I'm Steve, and in this problem we have a really difficult two-dimensional projectile motion problem. However, on the bright side, it is probably the hardest I can think of to do without involving calculus. In this problem, you'll be playing basketball. You'll need to figure out what is the initial velocity that you need on the shot in order to make a three-pointer that's about 6.7 meters away. And in this case, you're going to be releasing it at a 50-degree angle from 1.25 meters off the ground. And I provided a diagram for you to reference. At this time, please pause the video, try it by yourself, and when you're ready, I'll show you how I did it. Welcome back. Hopefully you didn't struggle too much with this one. First thing I did when solving it was knowing that I had to use the general equation that height is equal to initial velocity times time plus 1/2 times gravity times time squared, because we're going to be working in the y component. Next was to write out all of the known variables from the problem, which were the height of the release, the height of the rim, the various distances, and gravity itself. After that, I tried to figure out the initial velocity in the x and the y direction. However, since you don't know the overall initial velocity, I left it as a variable. Then I took that and plugged it in for time is equal to distance divided by initial velocity, as well as I figured out the change in height from the final position to the initial. I then took all this and I plugged it back into the equation height is equal to initial velocity times time, etc. And when you did that, it comes out with a complete mess and a bunch of variables that you really can't solve too easily. However, there are some substitutions that can be made. The first thing you can do is expand out the components of velocity a little more. So you can, instead of just leaving them sine and cosine, you can actually find what the numerical value of the cosine of 50 and the sine of 50 is, and plug those in so you can multiply that by the initial velocity. And then once you do that, make sure that you also sub those in to your equation for time. And after you've made all of those substitutions, make sure you substitute it back into the big equation. And if you did all those substitutions, afterwards you're left with an equally long and still very confusing looking equation. However, I promise you this one's a lot better because you have only one unknown variable, and if you write it out, it's much easier to notice that some things will cancel out. And you know it'll cancel out because there's an initial velocity in both the numerator and the denominator of that first term in the equation, which you can cancel out. And then once you do, now you have one unknown variable, the velocity squared, over in the last term. And then all you have to do is just do a little algebra, rearrange the equation, and get the initial velocity by itself. And when you do that, you'll find that the initial velocity is actually equal to 9.24 meters per second. I hope this problem wasn't too hard, and now you're able to go knock down those three-pointers like a pro, right? If you still do have questions though, please leave them down in the comments below. I will do my best to answer them. And if you liked this video, please leave a thumbs up and share it with your friends if you think it'll help. And until next time, have a great day.